Do we want to make this? Okay. All right, so it's a couple of minutes past 12, so maybe let's make a start. Welcome everyone to another installment of the Global Changemakers Series. This series is essentially a series of visits by international experts who come to Heriot-Watt University very kindly to share some of their knowledge with our students and our staff as well. So this month, we're very pleased to welcome Francesco Cerigioni, together with our own Dr. Marco Pellicia, and they will be talking about AI, economics, and the consumer mind. So over to you, Marco.
Thank you very much. Okay, it will be very odd to introduce Francesco for me because I know him since ages, but trying to be a professional, you know. So Francesco is a brilliant economist. The last academic position he had, it was in Pompeu Fabra, which is one of the leading universities in economics in Europe or around the world. Is a decision theorist, so which is a branch of microeconomics that studies essentially model consumer behavior, human behavior. And so he's a theoretician, but then decided to jump to the private sector, to the dark side, and to work for a startup, which is Bionomics, which is a very interesting startup from what I hear, who essentially, maybe he's going to give more details, but essentially what I understood they do, they model using cutting-edge techniques, model consumer behavior and markets. So essentially the companies can test all their strategies, like pricing strategies, on these models before actually implementing in the real world. So it's a really pleasure for me to have this conversation, because I think it's very rare to have an opportunity where you have a person with an academic background, so extremely strong in the economics and the techniques, but also has an experience in the industry. So it's very rare. Okay, so what I would like, I start to ask some questions I prepare. And the first question is it's more for you to introduce yourself, essentially. It's like if you can share a bit your journey from academia to industry, which is not necessarily very common, and particularly your transition from assistant professor in economics to your current role as a data science modeling lead, right, at Bionomics, and what motivated this shift? How do you find this experience, this transition? Was it difficult, was not difficult, and maybe you can share this with us.
First of all, thank you for having me here. It's great, and thank you, Marco. It is weird to be like introduced
by me.
I will try to keep it also professional as much as possible. So I would say there were many factors for my choice, for sure. Some of them maybe I shouldn't say in a university, but it's like, no, it's jokes apart, I would say mainly was because I wasn't feeling the fulfillment probably I should feel. So mainly was really personal choice. And then also we had some discussions today about that too. It's like I always had like a weird feeling with the educational system, in the sense that I think it needs to be reformed somehow to adapt to the society and how we grow together as a society. And I joined academia mainly because I thought it was the place for creativity and you know, bold ideas and try out things. And then I discovered, at least in economics, it wasn't really the case, let's say. It was much more driven by publications and what's the system is expecting of you. I remember, for example, my PhD thesis, many professors were like, in the interviews and stuff in the different universities, were like telling me I was crazy because I did a thesis that was completely out of the standards in the decision theory in economics. In particular, doing the decision theory too was crazy because it's theory, and no one does theory anymore. We are in the era of data. Theory is useless. There were all these things, and in the end, I decided to go where I think creativity still is. That is the private sector. And yes, I joined the dark side, as you, and fully embraced it, I would say.
Just it's like perspective. You might see dark side as academia. So.
No, exactly. No. It's obviously when you talk also about like these big manufacturers that they can simulate pricing and see what to do and you know, get more profits. You think, okay, this is not really good for society. But then if you start thinking a little bit more deeply, these are actually the main actors that drive changes in our society, unfortunately, whether we want it or not. And sometimes they just make bad decisions because they don't know the consequences of their decisions. So providing a platform where you can actually show the consequences of their decisions, even long term, it's actually much more impactful, I would say, than maybe the papers I published when I was a professor. Then, you know, no one reads, and probably no one read. And it's like, and that in the end motivated me. And I wanted to test whether I could find this creative environment, and I have to say I found it. It's like, it's super creative, super interdisciplinary. We have like colleagues from mathematics, from biomathematics, from engineering. So it's like, when we brainstorm, it's like super exciting because you see like many different perspectives. And you think about actual problems, you try to solve them, and you need to solve them. And you see immediately the impact of what you did, whether it worked or not. And that's also something I enjoy a lot because, yeah, again, I was also, they told me I was crazy when I left academia, obviously, because I mean, I had an established career, I had like a good publication.
Crazy, but yeah,
and
in a good
like,
way.
I have a family, so it's like not the best idea, but in the end, I think it's turning out quite nicely, and it was what I was looking for, and I hope we can make an impact somewhere. And then you asked about challenges. For sure there are. I would say the main one was mainly getting accepted because as the business world is like the dark side, obviously the academia for the business world is like the useless side of society. That's like, you know, when I was sharing my CV, it was like, okay, I mean, it will never contribute to anything. I mean, a theorist coming to do, you know, something with data, only saw academia in his life, was like, obviously there were all these preconceptions, let's say. And that was the hardest part, apart from, obviously I was used to, you know, do things with pen and paper and do, I don't know, mathematical theorems, because my field is very mathematical. I mean, was very mathematical. And suddenly I had to code with people that coded since they were 15, probably, and now they are 40, so it's like they are very good. And I had to learn a lot in the beginning. That was a little bit challenging, but it was fun, also fun.
So I just give an idea what Bionomics is. Maybe you can explain a bit better what Bionomics does, and connected to that, how do you think your experience in the decision theory, so your academic experience, actually inform your work in Bionomics? Can you give us a context?
Yeah, Bionomics mainly is directed toward RGM. That it's something I discovered when I joined. It's revenue growth management. It's something not all companies have, and it's a department that tries to make revenue grow, mainly. How do they do that? Mainly it's the department that has to decide, let's say, architecture of products, so that which kind of attributes they should have, branding, you know, even packaging and things like this, and then the pricing, how to do promotions, with which frequency, when, which kind of promotions, and all these problems, they have to solve them. And before was very manual, mainly based on Excels, and trying to find one elasticity and apply to anything and hope for the best. That's what made it. Because then that has a lot of implications, right? Because they would then they would try to predict how many units. So we work with the manufacturer. So it's like it's a double-sided problem, because then the manufacturer has to have contracts with retailers, like Tesco, right? So it's like then they have to predict how much Tesco is going to sell, to understand how much they are going to sell Tesco and when. That usually there is also a delay. So it's quite a complex problem, and there were no tools. And now some of them are starting to come out. What differentiates Bionomics is that it's very much focused on the technology instead of the interface, let's say. So standard tools in the industry would be more like demand forecasting, like with time series techniques. In Bionomics is completely different, because you can actually simulate the whole market. And so you can simulate, like, if I change, you know, the packaging to this other packaging, or the color to this other color, or the flavor to this other flavor, and I change the pattern of promotions and things like this, you can really simulate all the microeconomic impacts in the consumer choice, and then you can rethink your logistics. So that's where it's really leading the market in that sense. And in that sense, I mean, our clients for now are happy. Some of them I cannot share here, but some others are on the website, so you can see. But it's like really, really big manufacturers, like the main ones you can have in mind. Like I think on the website we have Danone and other of that size, let's say, and they take decisions through our technology. And where decision theory kicks in, I mean, I would say, one, it's obvious. It's like we are trying to model decisions of consumers. So that's choice. So anything related to choice theory is relevant. But then I think there is also a deeper connection between decision theory and machine learning. So that's where I actually, when I started deciding to do this jump, I started studying half an hour of Python each night for the last year in academia. And it's like I started understanding a little bit more these techniques, these famous algorithms that are behind all these things we know now. And in the end, you understand it's really about choice also there. It's what's like very important in machine learning, in particular like in what's called supervised models, where you give them a target, let's say, what should be the behavior, and they try to adapt to reach that behavior. In the end, it's really all about the machine making choices of which information is more informative or not in the data, and go towards the objective. And these trade-offs that you usually map them into what's called the loss function in the algorithm, it's actually decision theory too. And that's something still not fully understood in the industry, let's say. Some big companies do understand. Like, for example, Amazon is looking for, and their cloud technology is looking for decision theorists, because they understood that actually it's very important, but it's maybe the less obvious link, let's say. And I did it also because of that. So the change to machine learning was for that, and Binomics was also the natural step given the applications.
So connected to that, instead of say how these things using for business, then I want to ask you, like, in your view, given now you got experience of both world, like pure economics and now these new techniques applied to business essentially, how, in your view, can AI and machine learning, for instance, can enhance traditional economics models? We have here some people that already doing a bit, but how do you think that the direction is going to be for economics? How do you think AI and machine learning can develop economics further?
Yeah. So first, like, thank you for considering me a pure economist, because I probably no economist would say that, but it's like because decision theory is like useless. No, I would say, so it's like, I would say on the perspective is different. It's like, so let's start from how machine learning can help economics. I would say, like, economics, given it was based, like the mathematics of economics were based mainly on physics from the 19th century. It's very obsessed with this equilibrium concept and closed form solutions. That was physics of the 19th century. Physics moved on, economics didn't. That's, I think, the main thing where machine learning can help. In which sense? That it's like with machine learning, you can actually maybe abandon the idea of closed form solutions and start learning from data things that you might not be able ever to write down in a closed form solution, and maybe will never be in equilibrium, but you can actually simulate them. So it's like, it's closer, actually, it's closer to unorthodox economics, let's say. So it's like it existed, the field of economics with this, that is the agent-based modeling. Simon, Nobel Prize in economics. He got the Nobel Prize for other reasons, for bounded rationality. So that's actually, I know for that, because as a behavioral economist, I obviously love that field, but I also loved this idea of agent-based modeling. And Simon tried to say, look, we should abandon this obsession with equilibrium and closed form solutions and use the new computation capabilities we have to actually simulate the society and see what happens. It was just abandoned and not accepted in the mainstream economics. You couldn't really, I don't know, publish in Econometrica or Journal of Political Economy with just simulations, unless you were from a very, very top research department and, you know, good connections. But I think it's a direction economics should explore a lot. And then, like, on the other side, I also think economics can help, in particular, econometrics and all the theory we have on the, you know, topology of data and what you're learning from data and causality. All this can be very, very important for machine learning, because the field is a little bit. So, for example, my colleagues that are much more like the ones that are really specialized in machine learning, you can tell that sometimes they try things out just because, you know, I don't know, grid search, right? The grid search is this idea that you let the model search for the best combination of hyperparameters that are things that affect the structure of the model. Sometimes you don't need grid search. You just need to think about what you need to explain, what's the causality, the nexus you want to explain, and then you just go to the, you know, at least a reduced search or something like this. And these kind of reasonings are not that common in machine learning, because there is this belief that, you know, you give data and something will come out. But, you know, we do have knowledge as human beings. So we have artificial intelligence, yes, but we have also human intelligence. And maybe they can be combined. And that's, I think, where economics can help a lot in thinking about how the structure affects the final outcome of the model you have. Because there is also this belief that, I don't know, that's also a little bit in economics, and I never really liked it in applied economics. That is this idea that, you know, it's the data. No, you put some assumptions on the model you're using to describe the data. Linear regression, you're putting very strong assumptions. Other kind of techniques, you're putting other assumptions. You always put assumptions, because the data are nothing. It's just like how you explain them, and you have to understand what your assumptions imply for the solution you will find, the explanation you will find. And that's missing in machine learning.
So, in fact, can you give us some example, for instance, what are the challenges that you're encountering in modeling consumer behavior using like AI, for instance, or machine learning, how you address them? So in economics, most of the people here probably, and not all people are economists, but in a sense, it's easy for us to understand, for most of us, what are the challenges in building a mathematical model that predicts, that's what you're interested in predicting consumer behavior. As you mentioned, the fact that we are obsessed with closed form solutions, so we know that we need to make some assumption in order for the model to give us this solution, and then we can play with the solution. But essentially the math is really the issue for us, right? But what are the challenges instead when you use this type of techniques? So something like, for instance, you need specific amount of data, like, or what are the issues there?
Yeah, I mean, I would say it's similar in the sense that still it's the mathematical side, the most difficult one. But the difficulty there is related to the data you have. So it's like you look at the data you have to understand more or less what kind of information you can extract from it, how much information you can extract from it, and how much mathematical structure you have to put to actually extract the information you want. So it's like it's usually like this kind of back and forth between whatever the client can give you and the structure of the model, and so whether you can simulate something or not, you can approximate it or not, and how much structure you should put. So it's I would say it's closer to identification in economics, so this idea of really identifying an effect. These kind of reasonings help a lot in putting the structure that you need to understand from the data you have, and be sure that more or less what you're saying, that, you know, I don't know, the effect of putting something in display in the supermarket is actually that, and it's not a spurious effect you're capturing because of, you know, a wrong structure you put. So I would say that's the main challenge, yeah.
And given that I see some students as well, like a question I want to ask is that we already talked a bit before with Luciana and others, like given that here we are in university, is like, what do you think for students and professionals that are interested in combining economics and with AI, machine learning, these two things, what kind of skills and areas of studies would you recommend they should focus on?
Well, here probably we'll go a little bit against the flow, in the sense probably you would expect programming is one thing you should do. I don't think so. I mean, let me be clear. It's good if you learn. It's a language. You have to be able to read it at least to work with the others. But it's a language you can learn decently quickly to start interacting, and given the new tools you have as developer, like with generative artificial intelligence, you, as long as you understand and you can review code, let's say, check that the functionality works, and you know how to write a certain prompt, then you don't really need too much programming now, I would say. And given we are talking about students, I would say, given this as a certain pace, will be less and less relevant to actually be able to code, but to understand code, yes. And to me, that's the key skill. It's like understanding, be critical. So critical thinking, problem solving, and math, I think, is one of the fields that actually is built on that, on critical thinking and problem solving and definition. Those are things like, I would try to learn math and then apply math to anything I'm studying. In a way, that's what I did, but it's like, so if you have like passions, then you try to see how math can help there. For example, like econometrics, it's math. You have to understand what's the structure behind, but in the end it's math. And then also statistics, it's topology, it's math. It's like, so I would say math is a very good way of learning how to formalize a problem, frame a problem, and solve a problem, and then you can apply to the different fields and learn the other things in that field. And so it's like, if you have a passion for machine learning, I would say in economics in particular, I would go for all the theoretical courses you can and the applied courses you can, like econometrics as much as possible. Even if it sounds weird, I think
I would be happy. That side of the room, I would be very happy. Yeah, it sounds like maybe tell me if I'm wrong, but I feel that you're suggesting something like, given that the machines, in a way, they will do all these type of analysis themselves. Once you're gonna structure the things, then they do the stuff for you, in a sense. It's almost like, by learning how to phrase the problem in math terms, essentially what you're doing, you're learning the language of the machines. So it's for you essentially an ability to translate what you would like them to do in a form that can actually help them to perform for you.
Exactly. I mean, even if you look at before, like even before, good coders were not the ones that code like quickly, are the ones that solve the problem smartly. I don't know, efficiently in terms of memory, or efficiently in terms of computation, or both, and that's where you actually, and that's like, it's not how you code, it's actually how you think about the problem and how you solve it. All the famous algorithms for, I don't know, memory compression, all these things, they came out of ideas on the mathematical structure of the problem and how you map it to a logical structure. So it's like, maybe you should learn how to write an algorithm, like, you know, like an actual algorithm with the blocks, the decision block and arrows and stuff like that. That's much more important than learning how to write in Python. I mean, Python, you can learn it, but it's a language. But then, as any language, right? You can learn the words and everything, but then if what you're saying is not interesting, who cares? It's like, you should.
Interesting point. There's a question that I didn't think, and just thought while you were talking, is that, so if these things keep going on and evolving in the business sector, that's, for instance, more companies adopt the techniques that Binomics, for instance, offer, the services Binomics offer, what do you think it could be, in your experience, like an interaction between, so say there is Binomics 2, and is competing, essentially serving other competitors of your clients. And so essentially what we're gonna have, we're gonna have a suggestion on doing this price strategy instead of these, and the other algorithms, the other Binomics essentially will offer something against that. So it will become essentially like competition among AIs rather than managers. And how do you think this could be a problem or not? We might be entering a path. I'm thinking about this super fast finance, right? That it doesn't call it. It's not the right name, but I don't remember the name. Where essentially you have this kind of extremely fast algorithm that they interact very quickly, and sometimes you don't know exactly. Very quickly can diverge in something that you don't like. You know, if you have examples of, I remember an Amazon product, all of a sudden the price spiked to like $10,000 for
a book,
yeah, something like that.
Yeah.
So it could it be a problem?
I think 20,000
you don't
pounds.
have, yeah, exactly. You don't have your model that you, in a sense, you actually solved it, so you know that's how it's going to behave, and by instead is machine learning that's doing the job.
No, but exactly, that's to me, so yeah, that's like a bigger debate, but it's like, it goes in the direction of what we were discussing before. It's like, if you don't do the thinking, if you do not understand how it's working, if you do not understand the structure you put into the model, that maybe it's correlated with other models because everyone is using the same, then you will make a mistake, because you are losing the track of the structure that is solving the problem. And given you are putting a structure, it means some things will not solve them. That's the point. There is this idea that neural networks can do anything, but it's not true. It's still a structure. There's still some assumptions, and when those assumptions fail, you shouldn't apply that model. And so it's like you need more knowledge. You need to understand deeper, and then know when to stop the usage of this.
But there's a limit, right? But they keep saying that's,
Yeah.
you know, the advantage of working essentially using these things is that, as you said, in a sense, you don't have to do in a standard way in a closed form solution looking for that, but using data, which sometimes people say you're going to risk to have a situation where there's a black box. You don't know exactly why you reach
Yeah.
that thing. So instead, you're saying that still you have some control in a sense. It's not completely a black box. So what is the degree? What is defining like?
No, exactly. That's to me the new direction we should take. So that's what I think Binomics is. I think Binomics is really doing something unique in that sense. But it's like the new direction that anyway, if you look around, you see Meta is talking about these meta models, not meta models in terms of meta, but like a model of models, understanding when to apply certain model. And it's taking this direction that actually is the birth of AI. It's like AI was two main approaches. There was like, let's just use computation power, and then there was the other one saying, okay, let's use rules, logical rules. If A, then B. And obviously one won because computation and the Moore law, it's super, let's say, cheap to just throw data and see what happens. But it exists also the other one. And in a way, in Binomics, that's what we do. We try to not have a black box. Because, for example, also for real, so this came out in health issues with machine learning, for example, but also for us, it is an issue for our clients. Health, it's probably easier to understand, but for example, even a business like, I don't know, Danone, no? They have to take a decision, but then you have to explain it to the other departments. How do you explain something you don't understand?
You can't say it told me that.
You cannot say exactly, this thing told me to do this, we should do it. It's like no one will buy in and no one will do whatever strategy you found. So we need the model to be explainable, and we need the model to be understandable in that sense, like that you understand why something is happening and why something else is not happening. And this combination, I think, is the right path to actually do something with machine learning in the future.
It slow you down, probably, as you said. It's less, cheap, by doing it, but at the same time, maybe it's a good combine trade-off between pure theory, which to me sounds more like the standard economics, old physics, as you said.
Yeah.
And using as well partially like this kind of power of machine learning, and that maybe like this connected to the super philosophical questions I have at the end. So I was telling in the story that I think it's true. I checked the source and everything. It looks like it's true that apparently Karl Popper used to start one of his lectures. I don't remember which topic, but it was starting his lecture during the first lecture. He was entering the room. And he was saying to students, observe, and then we'll stay quiet. And then, after 5-10 minutes, at a certain point, there was always a student say like, sorry, professor, observe what exactly? And he was like, that's exactly the point. The point that if you don't have a theory, you don't know exactly where you have to look. And he was a famous critic of inductivism, right? In a sense, which is the notion that we gain knowledge just by the world purely through observation, which it sounds to me every time I hear about this machine learning and AI, sometimes I think like we are in a moment where we go completely in that direction, right? We just, as you said, you feed the data speaks, right? The typical stuff they tell you.
Yeah.
But he was exactly against that. And to me, it sounds that this like we're going back to this problem, like in a way. And so in the era, my question was, in the era of big data and advanced techniques, they're capable of uncovering this kind of infinite number of patterns, like, is this actually perspective even more relevant today? The fact that we can't abandon the fact that we need some sort of theory in order to choose which pattern is actually relevant. So what do you think?
Yeah, definitely. I mean, it's exactly. I mean, I remember when big data came out. This word big data was probably the beginning of 2000. Or
For me, you probably was just simply a large data.
Yeah, large data. Yeah, no, exactly. I mean, I remember we're at university and everything's like there was this thing, and I always felt, maybe because of self-preservation as a theorist, but I was like, no, this cannot work. I mean, this cannot work. It's just like I don't know, Google predicting flu epidemics through keyword search, and some keyword search made no sense at all. And I was like, okay, sure, it's useful. I'm not saying it's not, but let's try to understand why this keyword is in the end correlated with the flu. There has to be some pattern. I mean, I really believe in, microeconomic behaviors that then create macroeconomic effects. And we just need to understand them. And it's very relevant actually to do that, because otherwise, then I understand all this debate on, AI, the future of humanity and all these things is like, it's mainly about the fact that we do not understand what's happening, and we shouldn't live the thinking. I think that's where we can really give something. And that's actually, so I'm happy because I'm seeing in the industry now, I'm seeing that there is a backlash. So it's like, for example, in economics, I have a very simple example. Some of our competitors, they obviously, even our clients, I mean, they're so big that they try to do it internally, to create a model internally. And usually they fail, because usually they, I don't know, the main part they hire mainly, from machine learning. And they may be computer scientists. And they would go with the standard approach that I understand. They were taught to do that. They would apply some kind of algorithm. Usually, for example, for demand forecasting would be time series, and then maybe what's called categorical boosting and things like this to have. And maybe the model is like super accurate. I'm not saying that, but the problem is accurate in terms of what? Because then when they were simulating, I know, for example, a big fashion retailer in Spain that you can guess, like they had the whole department and they just fired all of them once they used the model, because it was like predicting, for example, positive elasticities. It was predicting that if you increase prices, units will go up. And no one could believe that, and also they observed it never happened. So it's like, and no one checked that. Why should you check that? The algorithm was working, accuracy metrics were working. The point is, and that's also related to before, like, are you measuring the right thing, right? So it's like, and that's also where decision theory can help. It's like, are the objectives correct? So it's like, is the metric correct for what you're doing? And many times it's not. For example, when they discovered that facial recognition algorithms were like terrible with black women, and they were like, "Oh, why? Why is that?"
Because they trained with white faces.
They were trained with white faces, exactly, and so male faces. So it was like impossible for the algorithm to understand who is this. I mean, I've never seen this, because it was the internet. And I did some tests on myself, like even like now with ChatGPT. Sometimes when you ask, I asked, can you draw a picture of a human being like laid in a bed in the fetal position, laid on a bed in fetal position, and it gave me a naked woman, like naked woman on the bed, and I was like, why? I said, a human being laid on a bed, no nakedness, nothing, and suddenly, because the internet again, it's like, then I checked. I said, let me check internet. If I put,
maybe you should not check.
Like sleeping, not true, but like I was like, and then like maybe 80% of the pictures were women on a bed to sell mattresses. And I was like, okay,
that's
obvious. But then if we do not track these things because we don't think deeply of what we are doing, what it implies for the algorithm, what we are doing, and we think the algorithm speaks by itself, no, the algorithm has a structure, and with that structure we find something. Yes. But you have to think about the structure and also about what you're feeding to this structure to understand really what it's saying. And that's the key for me, like where we need to, in a way, think again all the approach machine learning has and go back to the beginning of AI. Maybe it's very modern popper is Hegel, that I don't like, by the way. I love Nietzsche, but it's like, so, you know, maybe Nietzsche and Hegel were like really on the same word. But it's like, one thing Hegel to me got very correct is like about the history of humanity that goes from antithesis to thesis, antithesis, and synthesis, right? So it's like, and I see this in machine learning. So it's like in the 80s, it was all about logical rules. Computational AI was considered stupid. Neural networks are a very old idea, I think from the 70s. I don't remember the first paper, but it's like everyone said this will never work. Then, you know, laptop came with like a lot of computational power, and it worked. And then everyone is saying, okay, we don't need anything else. This is amazing. And then we start discovering biases. We start discovering. I think we are going towards the synthesis of the two approaches, and I think that can be good for humanity in general. Also for this debate of the future ethics of AI and. To me, what AI is showing is weaknesses of our society. So it's like we don't want to see it. We blame the algorithm because it's easier, but it's actually showing us all the weaknesses we have as a society in the educational system and all this. Like, for example, the fake news. Now they can generate anything. It's impossible to discern what's fake and what's not. Yeah, because we were never taught like to do that. The education system should be about that. In the age of information, it should be about discerning information. What's relevant, what's not, what's informative, what's not. But no, we still transmit knowledge that makes no sense once you can find it anywhere. You have to discern information. And it's like the algorithms are showing that. We are not able to discern information. It's not the fault of the algorithm, it's our fault as human beings. The algorithms are biased. We are biased. It's not the algorithm that is biased. So all these things is like, to me, it's much more about human introspection than about artificial intelligence.
Yeah, also Kahneman would say something, not of course not about AI, but in general about using algorithms. Despite, of course, they fail sometimes, they fail less often than human beings. So even if we say that, you know, it doesn't work all the time, it can create problems, using humans sometimes has the same. But in a way, what you said made me think maybe like, you know, you always hear doom story about AI, you know, the impact you're going to have in the workplace. It sounds like there's still space, there is a role for humans to essentially give that kind of structure you're talking about. And so, you know, that's maybe where we're going to work. We're gonna do type of works where we're going to be the ones that are going to give structure to AIs, which make more relevant theory, which maybe we're going to be, again, quite relevant.
Exactly. Exactly. I was actually...
be the antithesis.
You would be surprised how relevant theory is in the data-driven world. Yeah. I mean, in the end, I am enjoying a lot my job. And I changed position in 2 years. Like, I changed 4 times position because, like, it's relevant in the end, like understanding the structure behind the algorithms. And it's... I think is the direction we should take, and again, like I know I'm an employee of Binomics, so probably you will think I'm incentivized to say you should come to work with us.
As economist, yes, I was like,
you should come to work with us, but I really believe it. I really believe it. I really believe we can do something. I see Binomics as an amazing tool for simulating a society in the end. I mean, consumers in the end are just a particular society, but it's in building a foundational model of that, it's something that is the only company, you know. It's like because usually generative AI and these things are about images, are about text, but thinking about a society of individuals, it's there are not many companies doing that.
Okay, so I was thinking now to open the floor a bit to questions from all of you. So we have like more academics. Of course, the divide is usually in the room. You know, you have like this kind of homophily in terms of people like tend to separate. So because students look like a bit more, and then you got academics. But I would be happy to, to hear questions from all of you, if you have any. Oh, sorry. Yes, of course. I'll turn this. Any question? Yes, Shana.
Could you tell us a little bit about some of the use cases you've had with Binomics? So I know that you mentioned Danone, who are owned by Unilever. Can you tell us a little bit about how they used it in their day-to-day operations, if that is possible?
Yeah, I can tell you, then I will kill you, but it's fine. That's why they hired an Italian, you know. No, but it's like some things I can say. Yeah, it's like they use it really. Again, it's like RGM is defined on 5 levers, I think, big levers. Price is just one of them. So, but then there is the price packaging architecture, it's called. Then there is the promo planning. Then there are many things they have to think about, and they mainly use Binomics as, let's say, maybe for academics would be closer to understand. It's like the counterfactual tool for excellence. It's like they just build counterfactual scenarios and see what would happen. And it seems they are happy because it seems to be working. Because, for example, I know a use case from another client, UK based. They had like a competitor that really did a drastic change. And usually also, that's another thing, machine learning is good as long as the system doesn't change too much, because again, people don't think too much about the structure. So if you don't have a structure,
there are very likely events.
Exactly. And it's like, and is this idea also of data drift is called in machine learning, but this is the idea, if the system changes, you have to change the model. But if you have a structure, sometimes that's not needed. And that's what happened, for example, to us, like this client, they had a competitor that changed suddenly their pricing on all brands, I think of like 23%. That it's like a huge change in price. And they were panicking in the company saying, what do we do? What do we do? And so they simulated the change in pricing like in our app of their competitor, because they can do also that. And then they started thinking about what was the best strategy for them, for example, to limit the damage and maybe not affecting too much future behavior of consumers by changing too much price and then have to regret it or things like this. And it seems it worked quite nicely. So, for example, they had predicted they would lose, I think, something like 22, 20, I don't remember numbers exactly, like percent of units. And in the end was 21. The prediction from our simulation. So it was like they were very happy because for them it meant like billions. And so usually that's how they use it, like really to think about different strategies. And then we expanded functionalities to help them. And we have now a possibility that we call decision guide that actually guides them towards, for now, the best pricing, for example. So we try to find for them the best strategy in terms of pricing.
Excellent. Thank you very much.
Thank you.
So yes.
Thanks very much. Really fascinating talk, and I could ask you about 50 questions. I'd particularly like to know, you mentioned how you can't really, and you shouldn't rely on this call to authority of, the model has said this. So what are the strategies that you use in order to communicate the findings and the assumptions of your model to your clients?
It's very close to actually standard economic theory approach, in the sense that, you put a structure and you know that this structure implies some things. What changes with machine learning is that you try also to give flexibility to the algorithm to actually learn how strong these implications are and whether they are relevant for your use case. But the point is that you limit the behavior of the algorithm. So there are some things it cannot explain in a certain way. And this gives humans, like, comfort, because they can understand what's happening. They can understand, okay, it's like, okay, it's predicting this, because there is this possible chain of events inside the algorithm. We don't know the details, but we know it's possible, it makes sense that it's possible. And then the magnitude of the effect, okay, was the data. So it's this combination between human knowledge and, you know, what you can capture from the data. And that works, let's say.
I have 2 questions. One is, can you tell us a bit more about the details of your work? So have you abandoned completely math? Are you doing some coding? Or what is it you do in your daily, at work? And the second one is about, is there any hope for collaboration between industry and academia, or just a dream?
Like dog and cat, yes. No, I would say for the first one, my day-to-day is quite intense, that's for sure. It's like we are growing, so it's there are a lot of issues, then clients that come with new things. But I would say it's actually exactly what I was looking for when I started my career to be an academic in the beginning and do the PhD. So it's like I found this creative environment where I actually didn't abandon math. I'm doing mainly mathematical modeling. That's why, I mean, I'm the lead of the modeling department, and mainly it's like our responsibility to shape any algorithm we use, anything we use, and give it a structure, give it something that can solve the problems. So it's actually very, very much close to theory in that sense, but then you have to think about also information theory again, like for what you extract from the data and understand whether you can actually do that. And in decision theory, I was used to that, because it's like decision theory, I don't know how familiar you are with it, but it's like usually you do these axiomatic characterizations. That's mainly, you have to find the main properties of a model, what they imply. So if a behavioral model, for example, you say, I don't know, people are affected by the ordering of products on a shelf. Yeah, nice. That's what I was doing, right, as a theorist. I was trying to say, okay, I take these things from psychology. Now I need the mathematical model that can be applied in economics that does that, right? But you don't want to explain everything. You want to give enough structure that then some things you can explain and some others you can't. And those are the axioms. But then there is also the dark side of decision theory that is like, it's called the richness conditions. And these are more about the data. So it's like, suppose I observe these patterns in the data that comply with these axioms. Which kind of data I need to actually be sure that just these 3 properties actually fully identify the model I created? So it was always like that in my life, thinking about the structure of the model and thinking about what the data are telling you, and whether you have enough data to say that, or you have to change the model. And it's like, in decision theory, obviously, usually you change the richness condition, so you change the data, you say, okay, I just need more richness, fine. And you write the mathematical formula to have richness. In the real world, you can't do that, unfortunately, and then you have to adapt the model to the data to be sure that you are actually identifying something.
Yes, please.
Yeah, how can we ensure non-bias in AI when ethics is such a big issue in AI currently? Because obviously that's part of the decision-making process. Is it ethical to output that information?
Yeah, it's like, that's what, I mean, it's a very relevant question. It's like related to what I was saying before. Maybe I'm a little bit cynic on that way. It's like, I don't think the issue is with the AI, the issue is with human beings. And I think it's a very important issue that we are not facing properly. So to me, it would be more about how do we deal with all the ethical problems we have in our society as human beings. And then maybe we have a hope for the algorithms, but the algorithms are just reproducing our biases. So unless we address our own biases, there's no hope in that sense that the algorithms are not biased. That's my view, but I mean, yeah, take it cum grano salis.
There's a question there.
Do you want me to? Yeah, no, I just want to push on this point, the link between theory and practice. So I just want to kind of understand, I mean, so I understand that you kind of, there's some symbiosis, but the point is, so, you know, kind of the innovation that DeepSeek had was actually just, you know, new model with fewer parameters. You know, it works well. And so the question is, like in your work, do you actually go back to theory to just improve some the aspects of how you want to think about the world, apart from the data. Because, I think that's kind of crucial. I think you mentioned that, but I just want to know, kind of in your experience, given that you went to the other side in a way. I'm not going to call it the dark side, but I think it's the other side a little bit. It would be very useful to know, because kind of not knowing what else this is a problem, I think, right?
I agree.
In general.
Yeah, sorry, because then you made me remember. I forgot to answer that question, because now you said the other side, and yes, so it's okay. I'll try to answer both now. But it's like, so I'll start from the theory part. Is like, that's mainly what I do. So it's really about theory and thinking about the structure and how to put it in and exactly to me, DeepSeek, or even what ChatGPT, the transformer architecture was theory. It was just like a new way of thinking how to handle the data you have, and exactly that's where I think the real innovation is coming from.
You cannot publish a paper with neural networks in economics, by the way.
No, exactly. That's the problem. That's the problem with economics and academia. Okay, I'm sorry. I'm sorry. That's why I left. But it's you can come with us if you want. But it's we would be very happy. But it's like. But that's exactly, I think it's connected with the two things, right? So it's like putting structure and starting to understand that these things are not just perfect and do anything, but they actually have a structure, and some things they are very bad at and some things they're very good at, and you can improve on that through human knowledge is super relevant. And I think it's the new direction of machine learning, and all the innovations are about that. And that's not by chance that both transformers, the first architecture, and then now this one from DeepSeek, if you look at it, they actually managed to use less data, really. Then transformers, they saw it was so efficient that they said, okay, let's throw it even more to have more. But it's like, as an architecture, it actually uses less data to do what was possible before, by giving this idea of context instead of just thinking about time. So it's like, it's a different structure that worked, and that's where I think innovation can come, and that's where I think the connection between industry and university can work, because university obviously should be dedicated to be disruptive, to have a structure where you can think about new things, and maybe industry can help breaking these kind of patterns that are due just to the conservative system university is part of, and show to university, and mainly whoever founds the university and draws the laws, it's like, and the degrees, it's like show that transmitting knowledge in a society of information is really not important, but thinking creatively about new problems and stuff like that, and maybe collaborating on this creativity. And we were discussing this today. I think you have very nice initiatives here in this university about that, and trying really to, no R&D department in any company will be as good as a university if the university really starts to be interdisciplinary and focused in solving like that, and providing this kind of service to society. University has an edge. This is the economist in me thinking about, this from British economist Ricardo about, relative productivity. And it's like a university is unbeatable in that. You have amazing minds dedicated doing like research. So in an R&D, even we are probably the closest thing of an R&D we have, but still it's like not like a university. You have also to solve other things, and maybe quickly, and maybe bugs in the code, because then we code too. It's like it's different, and that's where I think the collaboration can really become fruitful and help each other, and not be the dark and the bright side anymore, and just society.
You need a bit the dark and the bright side, right? Star Wars teaches that you need for an equilibrium, so I'm happy for that. But any other question? Yes, Mark.
Your predictions which you produce for your clients come with inherent uncertainty, right? How do you convey that uncertainty to your clients?
That's a very good question.
Yes, he says he hates stars, he wants confidence intervals. So,
Yeah, you would be welcome in our department. So we agree with you, let's say, but that's, so to me that's also, if you think about it, again, sorry for being always blaming humanity. Maybe it's like, because I'm turning 40 probably it's because of that. But it's like, if you think about it, it's the same problem with weather forecast, right? It's like people then say, they were wrong, because understanding variance, or climate change. Climate change to me is the biggest example of that. People don't understand what, that just by raising temperature a little bit, you are actually increasing variance or whatever is happening. And so they say, no, today is very cold. Where is climate change? No, exactly, because today is very cold and tomorrow is very hot. That's climate change, and that's because the temperature went up, but it's variance. And it's a very difficult concept to understand because we are not trained to understand it through the educational system. And so when you deal with clients, those are some challenges, like you have to find way, and that's not up to me then. There is the whole go-to-market side of the company. That's the dark side, by the way. And they, I'm joking. They are very good into trying to explain these things. So we have a whole team that is called the customer value team. They do an amazing job about exactly on those things. So they try to make the clients understand these things that are not super easy to digest. We are also pushing for the interface to actually show intervals prediction, not point predictions, but that's, for example, clients don't want that. So it's like in the end, it's like you have to offer something that they buy. And so what you do usually, we are discussing these things, but let's see. It's like usually what you do is like both we do is you give the point prediction. It's much easier for anyone to understand in the company. And then we have the team that tries to explain to them how much to trust this point prediction and yes, like in which conditions that we might be off. But it's relevant. It's very,
Maybe we got time for the last question? No? Okay. So it's just almost spot on. So it's, thank you very much, Francesco. It's has been a pleasure. And again, as I said at the beginning, it's so rare to have like someone which has this kind of double experience in these two worlds. So it was great. So yeah, thanks also all of you for coming and for the questions. So yeah.
Thank you. It was a real pleasure. Thank you very much. Thank you. Thank you.